Hey everyone, this is the first video for the rational numbers unit. This unit basically takes everything you learned last year in grade 8 about integers and fractions and compiles it all together and challenges you to see how well you can kind of incorporate both integers and fractions into the same equations. Oh, and decimals. So, first off, just to let you know what a rational number is, the technical definition is any number that can be written as a fraction. So, any integer can be written as a fraction. For example, 10 can be written as a fraction because it can be 10 over 1. Obviously, a fraction is a fraction, and any decimals that terminate or repeat. By terminate, I mean it ends, so it doesn't go on forever. For example, pi is a decimal number that goes on forever, so pi is not a rational number. So 1.2, that's a decimal that terminates. A decimal that repeats, like 0.33 repeating, that can be written as a fraction. That's 1/3, as an example. So if you have a decimal that terminates or repeats, it's a rational number. So those are the types of rational numbers that there are. Okay, so in this first video, I wanted to go over how to compare and order rational numbers. So that's being able to take a look at two or more different numbers and identifying which one's bigger than the other one. Let's start off really easy. We've got 2 and 3. So which one's bigger than the other one? Well, hopefully you know this one. 3 is bigger than 2. Now, what if we're dealing with negative numbers? -2 and -3. This is where it's pretty common to make a mistake because you see the 3 and you think, oh, 3 is bigger than 2, so that's my answer. That's actually wrong. When you're dealing with negative numbers, the sign is always opposite because the way that helps me to remember is a number line. So let me just draw this really quickly here. -1, -2, -3. Okay, so you can tell these numbers on the right here are bigger than the ones on the left. So when you're dealing with negative numbers, the closer the number is to 0, the bigger it is. So -2 is actually bigger than -3. So that means we'd be drawing this the opposite way. -2 is greater than -3. So anytime you're comparing two negative numbers, all you have to do is remember that the sign is opposite of what it would be if both of the numbers were positive. Let's try an example with decimals. -2.4 and -2.45. Personally, the way I would like to think about this is I'm going to ignore the negative signs and just think about if they were both positive, which number is bigger than the other one, and then I'm going to flip the sign, and that would give me the right answer. So 2.4 versus 2.45. Well, this is 2.40 and 2.45, and since the 5 and 0 are in the same place values, and 5 is bigger than 0, that means the one with the 5 is our bigger number. So normally, if both numbers were positive, I would write a sign like that, but they're both negative, so I'm going to do it the opposite way. There, so that's my answer. So -2.4 is actually bigger than -2.45. Now let's do an example with two fractions. Alright, so we've got -3/8 and -5/16. So there's two different ways of solving a question like this. I'll show you the first way first. We need to get both denominators to be the same. Once they're both the same, then we can compare the numerators together. So we can get from 8 to 16 by multiplying by 2. Do the same thing to the top so the fraction doesn't change. And so this is going to become -6/16. Okay, compared to -5/16. Now that the denominators are the same, you can basically completely ignore them and just look at the top. So we've got -6 and -5. Now if I were to ignore the negative signs, I know that 6 is bigger than 5, so if they were both positive, I would write 6 is greater than 5. But they're both negative, so I'm going to flip that answer and write it the other way around. So -6 is actually less than -5. So that's what the answer would be in there. Another way to solve a question like this, and actually I prefer sometimes, is to convert the fractions to decimals. So for this one on the left, I would do grab a calculator, do 3 divided by 8, and I would get 0.375, but there's still a negative sign in front. And the other one, 5 divided by 16, gets me 0.3125. Oh, and that's -2. Okay, so I know that the 37's bigger than the 31, so I would put an answer of greater than, however they're both negative, so I'm going to flip it and write it the other way, so there's my answer. So either way works, you can just decide which works better for you. Okay, real quick, the last example I wanted to give you was when you have a combination of both fractions and decimals. So here are 4 numbers, and the question is order them from least to greatest. And actually this is taken straight from your notes. Now, anytime you get a question that has a combination of fractions and decimals, my advice is to always convert the fractions into decimals as well. So we've got 6 1/4 to convert into a decimal. So that's going to be 6, and then 1 divided by 4 is 0.25, so it's going to be 6.25. 6.1, -2.2. Okay, and -2 3/10. -2 stays the same, and 3/10 is 0.3, so it's going to be 0.3. Okay, we know for sure that negative numbers, of course, are smaller than positive numbers, so those are going to be our first two. So we have to think which one's bigger than the other one. Now, if I were to ignore the negative signs, I know that the 2.3 is bigger than 2.2. But since they're both negative, it's going to be opposite, so that means 2.3 is actually less than -2.2. So that means the -2.3 is our smallest number. After that would be -2.2. And now, with the positive numbers, 6.1 is, since it's a 1, it's less than 2, so 6.1 is going to go before 6.25. And that's it.